Okay, this question has tons of probabilities from a two-way table. I strongly recommend you to work some of these out on your own and use the video as a check. I'm going to go out of my way though to just put into practice some of the rules we've got, so you might want to look at some of the detail. Right, but the first one, probability of being male. I've got a total of 70 students, so it's going to have a bottom number of 70, and of the students, 40 of them are male, so it's 40 over 70, cancels down to 4/7, so you can get a decimal. Probability of studying Russian. 21 Russian students, again, the total is over 70. I'm always going to get 70 on the bottom until I hit ones like this. This is a conditional event. So this is not the probability of male and Russian, it's the probability of male given they study Russian. So now I'm only interested in the 21 students who study Russian. So that's 21 on the bottom. How many of these 21 students are male? Well, it's just these 14 here. So it's 14 over 21. Okay. Now let's work out the probability of being male and studying Russian. Well, I could do this directly from the table, but let's actually practice one of our rules. This should be the probability of being Russian times the probability of being male, given that I know that I study Russian. Okay, so our probability of studying Russian is 21 over 70. And the probability of being male, given that I study Russian, is 14 over 21. Okay, which may look like a horrible calculation, but in fact the 21s cancel. This is the same thing as 14 over 70. Okay, which is, if you cancel them down by 7, 2 over 10, it's 1/5. Okay. So I could have done it by multiplying these probabilities. In fact, I have. Or I could do it directly. What's the probability of studying Russian and being male? Well, I'm out of 70 students. This is not conditional. This is out of the whole 70 students. How many are male and study Russian? Well, it's this 14 over 70, which is the same version of the answer I got there. So it's probably more straightforward to write this down from the table, but we're showing that our multiplication rule for probabilities actually works, as long as I use the conditional probability. Okay, well, the next one is the probability of being male or studying Russian. Okay, well, let's do it directly from the table. So if I'm male or studying Russian, it means I could be any of these male figures here. There are 40, or I could be any of these Russian people, but I've got to be careful here. If I look at all the ones that are male or Russian, I mustn't count that 14 twice, so it's 40 plus 7. So the answer is 47 over total number of students is still 70. The other way I can do this is with the rule that the probability of M or R is the probability of M plus the probability of R minus the probability of M and R. And I've got all of these probabilities already, so this would have been a fairly good way to do it. Probability being M, let's stick over 7. Let's go with 40 over 70, because they're all going to have 70 on the bottom. P of R is plus 21 over 70, minus the probability of M and R I've got over here, 14 over 70. And if you do 40 plus 21 minus 14, it's all over 70, then lo and behold, you get 47 over 70, again using the rule. Either way is fine. Okay, the next one is the probability of being Russian given that I'm male. Well, remember, this is a fraction. Okay, using the rule, we've got the probability of being Russian and male on the top, and male on the top, and we divide by the probability that comes after the given sign over the probability of being male. So probability of being Russian and male, okay, is the same as the probability of being male and Russian. Okay, it's 14/70. Okay, it's going to be more convenient with the 70th version. And on the bottom of the fraction, the probability of being male, here it was 40/70. And as we've seen before, the 70ths can cancel, and I end up with 14 over 40, which is the same as 7/20 if you like. Okay, how could I have got this more directly? 14/40. Well, I could say I'm given that I'm male, so I only need to look at the 40 male students. And how many of those are Russian? 14 are Russian. So 14 out of 40 is the probability of being Russian if I already know that I'm male. So I could have got straight to this answer. And notice with the conditional probability from the table, that's when the bottom number is something other than 70. It's down to 40 because if I'm given that it's male, I only need to consider the 40 male students from the table. Okay. Next one, probability of being not Russian, well, that's very easy. Probability adds up to 1, so I need to do 1 minus the probability of being Russian, which is probability of being Russian was 21 over 70, so it's 70 70ths, that's 1, minus 21 70ths, which is 49 70ths, which cancels down actually to 7/10, doesn't it? 0.7. Okay, so I can do it from the previous answer, or if I wanted to, I could add up all of the students here, French and German students. I could add up the 29 plus the 20 to get my 49 over 70 that way. Okay, and the next one, the probability of studying Russian, that bracket shouldn't be there, probability of studying Russian given that I do not, that I am not male. Okay, well, let's use the formula first. So that's the probability of studying Russian and M dash, not being male, over the probability on the bottom is the probability of not being male. What are the probabilities? Well, okay, I haven't got any of these set up already. The probability of being Russian, and that's effectively female, isn't it? So the probability of studying Russian and being female is this 7 here. So that top probability is 7 70ths. So this is 7 70ths on the top. And the probability of not being male, the probability of female, therefore, is 30 females out of 70 students. So it's 30 70ths on the bottom, and when I cancel my 70ths, this is 7 30ths. Okay, or I could do it directly from the table. So what am I given? I'm given that I'm not male, so that means the only part of the table of interest is these 30 females, and I want the probability of studying Russian given I'm female. So 7 of the 30 students are studying Russian. 30 of the 30 females, 7 study Russian. So the conditional probability is 7 30ths. So I've got that answer 2 different ways. Okay, I'm going to do this one directly from the table because I think that's easier. If you've got the table, conditional probability is very straightforward. So I'm given I'm male. So in the table, I'm on this top row of the table. I'm one of those 40 students, and I want the probability of, what was it, R dashed? Yes. So how many non-Russian studying students are there? It's these two added together, 16 plus 10. So the answer is 16 plus 10 of the 40 male students. So that's 26 over 40, which you can cancel down to 13 over 20 if you like. But that's the answer. Okay, the probability of not being male and studying Russian, well, it's not conditional, so it's going to be out of 70. Probability of this is female Russian students. So on the table, I'm not female, I do study Russian, it's those 7 there, so it's 7 70ths, okay, which I get the urge to cancel down to 1/10. And finally, the probability of being male or not studying Russian. So it's not conditional, so it's going to be out of the whole 70 students. Okay, so let's see how many male or non-Russian students I can find. Okay, well, all of these 40 are okay. This is okay, this is okay, this is okay. All right, but also these French and German students, they're R- students as well. So in fact, it's all of these probabilities, all of these people combined. So it's all apart from these 7. So I can see they add up to 63 because there are only 7 missing. So it's going to be 63 70ths, 63 70ths, which is 9 tenths or 0.9. Okay. Decimals are definitely fine when they're exact decimals. If they're recurring decimals, then leaving them as fractions might be a good plan. Okay, so that's how we do that. And then finally, determine whether we've got some independent events. Remember, our test for independent events is that the probability of them both happening, A and B, is the probability of A times the probability of B. So I'm going to work out the probability of being male, the probability of being Russian. I'm going to multiply those together and compare with the probability of being male and Russian. All of these probabilities I set up higher up the question. Probability of male was the very first one I did, 4/7. The probability of studying Russian was 21 70ths, okay, which I haven't cancelled down yet, but it does cancel down to 3/10, okay. And the probability of being male and studying Russian, again, I've got that earlier. It was this 1/5 that I got earlier. All right, so the test is, do I get the same answer, 1/5? Do I get that by doing 4/7 times 3/10, okay, equals 12 70th, which does not cancel down and is definitely not equal to 1/5. So therefore the answer is they are not independent. Okay. And being female and studying French, okay, so the same thing. Probability of M dashed, all right. Well, I haven't got that yet, but if it's 4/7 for being male, it's going to be 3/7. 1 minus 4/7 is the probability of being female. Probability of studying French, I haven't got, but there were 29 French students out of 70 altogether. So that's 29 over 70. Okay. And then I've got to do the probability of M dashed and French. So the number of French female students, French studying female students was 12 out of 70. Do I get the right answer by doing 3/7 times 29 over 70? Do I get 12 over 70? No, I don't. I get something horrible. I get 490 on the bottom. I get 3 times 29 is 87 on the top. Nothing cancels. It certainly isn't the same thing as 12 70ths. Do its decimals if you prefer. So therefore, these are not independent either. Okay.